We have a special guest today, somebody from our grad school days. Nii is one of our close friends as well. He's like an expert in structural engineering. I think we'll have a great conversation.
I've always been a big fan of the show, so I'm happy to be a guest. As a student, my dream was always to become a pilot. My parents are dentists, and I was after working with them one summer, I was like, I don't think I'm doing this job. Looking into people's mouths, that's not my calling for sure. So engineering was the next best thing. Math, physics, those worked well for me. So like, how do I build onto those? So building onto those with airplanes, I was like, aerospace might be the way to go, and that's how I started off.
Has there been any extremely weird requests, especially while you were working in the private jet manufacturing company, structurally, that you had to make as an edit to the aircraft?
With private jets, you have athletes going onto these aircrafts. These guys are much larger than the average human being. So there's always this condition of how heavy can the person be to be on this door, on this staircase. And there was one time they gave me a weight to check if the door would still hold. And I was like, who is this person? You might have the weight and you have to usually add an extra 50% to account for things that could go wrong. Somebody jumping on the door, for instance,
right,
to make sure there's enough deflection so that it never touches and the paint job is never scratched. Oh my goodness, this door thing is a challenge on its own.
Have you ever had like a request asking you to open the doors like a Ferrari or something?
No, that we don't change. It opens downwards with gravity, that's it. But no, Lamborghini, Ferrari doors, that would be interesting, but no. That I don't think I've got that request yet.
Honestly, while we're talking about certification, it is my belief that aircraft structural integrity is the backbone of safety and certification for any aircraft.
Throughout the life of the aircraft, the structure is mostly unchanged. You're not taking off the wings and putting on new ones. There are very many sections of the aircraft that you do not see, that nobody goes in once it's covered up. So it needs to last the entire life of the aircraft. People just assume that, we just worked on brackets as system stress engineers, but it's a very complicated system. You're working on structure that people don't feel is very important, but you're going through primary structure as well and need to understand the flow. And also even the interaction within systems. If you have electrical systems, you need to make sure they're not really interacting with any fuel systems. And if they're hydraulic systems, that they are separate, and they're still running along the length of the aircraft. So there are all these considerations that you need to have.
So, does that mean there is a need for more structural engineers in the industry?
There would always be a need for structural engineers. It's always going to exist. I know we talked about AI. No amount of AI is going to replace a structural engineer. It's similar to, we're always going to need more pilots. The more planes you produce, the more pilots you would need. I see the linear correlation with structural engineers as well. I don't see computers flying the plane or AI flying the plane, but they would always be a supporting member of engineering and pilot community.
Have you sat in an airplane that you worked on?
Well, I've sat in an airplane, yes. Well, so with a commercial, yes, I've sat in most of the planes that my company makes or manufactures. With a private jet, I have sat in it while it was sitting on the ground, but not during flight. Yeah, and trust me, it was one of those experiences where I'm like, it pushes you to think, I'm like, it would be nice to be a billionaire, millionaire one day, because that experience of sitting on a seat, it was something different. It does change your life for sure. It's always good to dream. So I would say yes, I'm shooting for the stars. So yeah, at some point to own a jet that I know I have worked on, that
right,
would, I think, the peak of my existence. What keeps me in aerospace is the ability to work on something much bigger than myself. So it's like you're working on these planes, you know that, hey, at some point your loved ones are going to be sitting on these planes, so you cannot afford any fatalities, any casualties, any part of the structure that's failing. You always, and it's all to do with integrity.
Hello, everyone. Welcome back to another episode of Ground Control to Major Nerds. Today, I have with me my co-hosts Ashwini and Parvesh. Ashwini, how you doing?
Good. Really excited to be back and interview another really interesting guest today.
Yeah. And how's your week been so far, Ashwini?
Busy, been traveling in a new location right now, but looking forward to heading back to Mumbai soon.
Great. Okay. Parvesh, how you doing?
Pretty good, pretty good. Had a nice week.
Where are you right
Met
now?
a few. Bangalore.
Okay. You said
Yeah.
met a few whom?
Met a few cousins of mine. Caught up. Pretty chill week.
Awesome. All right, so we have a special guest today, and this is somebody whom we know from our grad school days too. So we have Nii, and Nii is basically one of our close friends as well. Back when we were at Riddle, we used to hang out together, and we actually were thinking about who could be the guest that we could bring in to talk about more of like aircraft R&D. And I thought Nii would be the best person to bring in since he's like an expert in structural engineering. So, I think we'll have a great conversation. So welcome, Nii. How you doing?
Thank you so much. Yep. Oh, thank you for inviting me. I'm glad to be here. I've always been a big fan of the show, so I'm
Oh.
happy to be a guest. Yeah. Yeah.
Wow, we have a fan too. That's amazing to hear.
He has to
Thank
be.
you.
He's our friend.
That's true, but still, nobody said that to me. So, this is great.
Yeah.
Good to hear
Yeah.
that.
I'm glad I'm the first then.
So, how
Yeah.
has your week been so far, Nii? Like, how are things?
Well, this week was actually a very simple one, short Monday to Wednesday, because Thursday, of course, was Thanksgiving. So it was all pretty much. I hosted a Friendsgiving, had a good
Nice.
time, had some good food, and that was pretty much it for me. Yeah.
So, where are you located now, currently?
Yes, I'm currently located in Wichita, Kansas. So I
Mhm.
got a job here and I moved from Savannah, Georgia, where we originally used to work, to
Yeah.
Wichita, Kansas. It's in the middle. It's pretty much the dead center of USA. So that's where I am right now.
How are you liking Wichita so far?
It's also a small city. So the vibe is very similar to Savannah, Georgia, where we have about 200,000 people in the population. There's no major sports team in terms of things to do. It's the smaller crowds. There might be an ice hockey game here, a basketball tournament here, but it's mostly college sports. Because in Wichita, we have one of the big schools, is Wichita State University. So the athletic teams are the big thing to watch over here. But apart from that, there are also major aerospace companies located around here. So that's the good thing with this city. It's filled with aerospace professionals. There are people moving around all the time. And yeah, you definitely meet new people in the field every single day.
That's amazing. Yeah, that's fun. I always heard about Wichita to be one of those places surrounded by like a lot of aerospace companies and like, just bumping into aerospace mines all the time. So that's great. All right, so let's start off with your your journey so far. So where did you start off? How did you get motivated to do aerospace engineering? How did it all begin?
Yeah, it's a very interesting one. So as a student, my dream was always to become a pilot. And yeah, my when I was in like junior high, I went to our Air Force base and I saw the quality of the planes. I was like, yeah, this pilot thing might not work out. What's the next best thing? And I was like, okay, fine. Engineering might be a possibility because my parents are dentists. And after working with them one summer, I was like, yeah, I don't think I'm doing this job. Looking into people's mouths, that's not my calling for sure. So engineering was the next best thing. Math, physics, those worked well for me. So like, how do I build onto those? So building onto those with airplanes, I was like, aerospace might be the way to go. And that's how I started off. So undergrad was in Delft University of Technology. So that was in the Netherlands. I was there for 3 years, moved back home to Ghana. So I worked for the Ghana Civil Aviation for almost a year. But that was more paperwork. So it's paperwork, regulations, ensuring that the airlines are doing everything to code. But I was tired of doing just paperwork. I was like, I've done so much math, so much calculus, so much in terms of differential equations. Where can I apply it next? So I got an opportunity for grad school in Embry-Riddle Aeronautical University, and that's where I met you wonderful gentlemen. And that is it pretty much for the college life. And yeah, how I went through from the start to the end of college. Yeah,
That's amazing.
yeah.
So what did you do in TU Delft? Like, what was your course?
So in TU Delft, it's specific. It's you pick aerospace engineering, and that's for the first 2 years. You're doing things like statics, mechanics of materials, calculus 1 and 2. You're doing introduction to aerospace. You're also doing like aerodynamics courses. The only time you get to break away is during your 3rd year, where you have the aero concentration, the structural concentration, the design concentration, and you actually even get to break away. So it's the 3rd year is like your elective period. The first half of your 3rd year is your elective period, where I actually didn't even do anything aero. I decided to do a project management elective. So that's where you're learning about business, scheduling projects, even data analytics, you're going through some of that. So that was the breakaway. And then the last part of your 3rd year, that's where you do your design exercise, so your final design project. And it's the beautiful thing about Delft was it was a 3-year course. So long as you weren't failing any courses, you were done in 3 years out of it. So that was the good thing with European education. Yeah, very quick, very specific. There was nothing about, doing courses, breaking you away unless you chose to in your 3rd year. But everything else from day one, it was like straight to statics. There was nothing about like building the foundations. You were supposed to have it. They assumed that you had it. So
Yeah,
that was the good thing with European education.
that's amazing. So at Riddle, when you came to Riddle, I mean, I remember you like, taking really hardcore, aerospace courses. So what changed your mind? Like, I mean, you can actually talk about like, how was your Riddle journey like?
I say Embry-Riddle, the main thing with Embry-Riddle was getting used to the American system. I thought it was going to be a continuation from Delft to USA. But quickly going back to Delft, where most of the grade in Delft was your final exam. Or if it was a course that dealt with projects, it would be the project grade where you are working with a group or a team on a particular project, like your final design project. But with Embry-Riddle, let's say you have homework, you have quizzes, you have midterms, you have the final exam, and then you might have a project. So there were all these different things within the course that came together to give you like a very good grade. With Delft, if you fail the final exam, you most likely failed the course. That's how it went. So it was like a one-time offer with Delft, whereas Embry-Riddle, there were different opportunities to make up the grade. Let's say you're falling behind on homework or midterm didn't go too well. You still had a chance to pass the course with a decent grade. So that was the main difference between like Delft and Embry-Riddle.
But in terms of like the courses that you chose at Riddle.
Okay, so Embry-Riddle, I focus more on structures. So that was the concentrations were structures, aero, controls from the top of my head. But I focus more on structures because I felt structures is more legacy aerospace engineering. Of course, you do need programming and technology for like all your computer automated systems, your fly-by-wire. But I really enjoyed my structures courses during undergrad and even in grad school, I did enjoy them. So that is why I decided to focus mostly on that. I started with doing courses like advanced structural dynamics. Um, and in Embry-Riddle, you also had to do math courses. There
Right.
was a math analytics course that I remember doing. So you did a math course, and then most of my other courses were also structures related. I remember doing a course like smart materials, which was supposed to handle the newer materials that we see on aircraft today, because those are also always evolving. But yes, in terms of the legacy structural analysis, that never really changes. So that's the good thing. And that's what I enjoy most about structural engineering.
That's amazing.
Yeah.
Just to be honest with you, like I had the similar journey with you, right? Like
Yeah.
going to Hertfordshire, same kind of model as
Yeah.
Delft. But as soon as I found an opportunity to leave structural engineering, I
Yeah.
left because I could not deal with the math which
Yeah.
was there in it. So it was just excruciatingly painful for me. So I always wondered, like, how did you guys like, like, how did you guys like, how do you guys even choose to do that? Like, it was always like a thing that shocked me. You guys, and then the flight sciences
Yeah.
and stuff like that.
The guys who specifically do aero, because like aerodynamics is you're dealing with fluids and air that you can't see. So I'm like, okay, yeah, your wind tunnels and your calculations, I want nothing to do with that. So I have the same feeling, you know.
Understood.
That was my jam.
You guys were much better at math than me, so I can understand why you all in this, you all chose all the subjects. That's why systems engineering is not like filled with math and physics more than like,
So
filled with.
how much do you hate systems engineers, Nii?
They're actually very important. I know we'll get to it, but I was during my stress engineering days in my first company, I was a systems stress engineer. So we'll get to that. Yeah. So they are
Yeah,
very, very
I have
important.
I have questions for that, so don't.
Yes.
Yeah, but
Nii has taken the political answer.
there are things like where structural engineering like is very intense with math, and that's why I moved away. But at the same time, systems engineering is very intense with planning of the whole design process, and which is also very different. Like it's a different kind of analytical game there. So yeah. Anyways, all right. So Riddle graduation happened, and
Yes.
then what was your first professional gig after that?
Okay. I'll go back slightly to my internships.
Yeah,
So
sure.
during grad school, I did one internship with an airline in the south of Florida. So that was a couple of months. That was the spring semester. Came back to school, and for the summer, I got an internship with a private jet company. So that was the foundation. So, of course, private jet company, went back to school, graduation, and right before graduation, I did get two offers. One was an internship with the same private jet company, or the other opportunity was a full-time job, but this was a different aerospace company. They make commercial jets, but the only challenge was it was like a 2-year contract. So I was like, okay, let me take my options with the company, the private jet company that I do know. I do know people. I do have contacts there. And that is where I went after graduation as an intern and eventually was able to convert that to a full-time offer as a structural engineer and was there for a very good amount of time. Yeah.
Great. So I think I guess that's where I met you as well. I mean, at Riddle as well, but again, we bumped into each other there as well.
Yeah.
So like so what was it like different from like academics to transitioning to professional life?
That is a very interesting question because academics is more of everything seems to rely on you in terms of you do your homework, you do your midterms, you get your grade. But with a professional experience, you're doing it as a team. Everything is a matter of your work is feeding into the next person's work, and that is for the overall structure of the aircraft. So it's like a group effort. No single engineer works on every part of the plane, from the electrical to the hydraulics to the fuel systems. It's like one guy works on this, and that feeds through some parts of the structure and how it's supported. And then you need to continue coordinating with all these different teams. So academics is more you. Yes, you have your friends to help you out, or you help your friends out, or work together in a group to do your homework. But you could do it by yourself. With professional experience, you're doing it with the team.
Got it. So the full-time journey, right?
Mhm.
how was that like? Because I believe we both were in the same journey, kind of
Yes,
like we're transitioning from internship to full time.
yes,
How was your experience of like becoming a full time finally in a proper
yeah,
aerospace company?
yeah. It was because I was an intern and then going towards full time. So at the interesting thing was I wasn't a structural engineering intern. I was a loads and dynamics intern. And for some reason, there weren't like any job opportunities in the team that I was in. So I was interviewing with different teams, and this structural engineering thing came up. And I was like, fine, let me interview. I interviewed and then got the offer. And I was really grateful because it was a journey of the internship was coming to an end and I had to convert it. And I didn't know if it was going to happen or if I had to find something else. But eventually it all worked out. And yes, I was grateful to actually be a full-time, employee within the company. So yeah.
That's great. So yeah, I think this is a good segment where we can actually talk about what a structural engineer is
Yes.
professionally. So
Yes.
what do you think, like in your opinion, like you said, loads and dynamics is different from structural engineers. So who do you define as a structural engineer?
Okay, so structural engineers, in most companies, you hear them being called stress engineers, but for simplicity, structural engineers, these are guys who look at the aircraft. You have the skins of the aircraft, you have the wings, you have the fuselage, like all these different parts of the aircraft that you need to come together to make it complete and whole. So structural engineers look at your joints, so your bolts, your rivets, the sizing of how thick your skins need to be, the frame sizes, everything about the structure that holds everything up. And one of the main understandings you have to understand is what sort of loads the structure is going to experience during the lifetime and how long. So, for instance, you have the engine vibrations, for instance. Your heavy landings because during a crosswind, for instance, I mean, pilots try to make all these corrections. They might have a heavy landing. The landing gear puts a large amount of load into the aircraft. So there are all these understandings of loads, how to size the aircraft, the different sections of the aircraft, and even emergency landing situations. Let's say your engines, for instance, there's a single engine failure, or all of a sudden your aircraft becomes a partial glider because instead of two engines, you have one. So with those, your landings aren't as smooth as they're expected to be. You have to consider all these different things. Gusts are also another big factor because all of a sudden, if you're sitting next to the window, next to the wing, you see during like high gust conditions, you see the wing bouncing up and down. Some people get scared. That's also part of what we do. It's supposed to flex. So that's the main core, in a nutshell, what the stress engineer looks at. But there are different fields of stress engineering. For instance, like for a long time, I was the system stress engineer. So with the system stress, you're looking at your fuel systems. You have all these pipes going through. You need to attach them such that there's nothing like they're falling off. There's nothing like the tubes are thick enough such that if a tube breaks for a fuel system, that's a disaster waiting to happen. So you're making sure all those things do not happen and then making sure you have all the preventative measures. Yeah.
What's a typical day like in the life of a structural engineer? How much of it is paper? How much of it is on software where you're doing simulation, where you're doing drawings, structure design, stuff like that? And how much is it actual real life testing?
Okay, it all depends on which stage of the program you're at. So in the beginning stages, so that's usually do your preliminary design. You'd hear a lot of people talk about like the hand calculations. So hand calculations are in the sense of you need to understand, okay, you have this amount of load going into this bracket, for instance. This bracket holds up a hydraulic tube. So with that, you understand your basic, you have a bending stress going through, you have possibly a shear stress. You hear stresses. People talk about stresses. So those are mostly like the day-to-day hand calculations. In some cases, you have a piece of structure that is complicated. For instance, you have the nose cover, which is called the radome, for instance.
Radome.
And yeah, so with the radome, in most cases, it's glass fiber. You don't have direct hand calculations for that. So you might put that in a simulation. So you have all the software, you have your aero loads, your bed strike, because those get a lot of bed strike impact. So with those, you have simulations. And then apart from the hand calculations, the simulations, as you mentioned, there's testing. So another test that I was lucky to be involved with was the wing bend test. So in some cases, they bend the wing up, you see it going up until it fails. I didn't get to see it all the way, but I did see it flex up very significantly. So that's one of the tests I experienced. And it's it's all there are all these requirements that are put in place by the FAA as to what needs to be tested. In some cases, you would have a pressure test of the fuselage to see what expands, to see if all the windows and doors stay intact. So it depends on which team you're on, but there's definitely a part of testing and calculations and simulation that you have to go through.
So to follow up a little bit on that, looking at it from a business perspective, right? I'm sure most of your managers or upper management would say, "Oh, you need to cut costs here, cut costs there." So from a design perspective, coming from your perspective, what is the place where you feel like companies cut corners where they shouldn't?
Well, in most of what I've seen, I wouldn't say there was any um corner cutting, but there was an emphasis on continuous improvement. That's one thing they were like that was ingrained in us because they would, with structure, there's always a way to reduce the amount of material you use. For instance, let's say a bracket, you need to make sure it's safe. It passes all the requirements. It is able to carry the load that you put into it. So it was more like continuous improvement. The only catch with continuous improvement is there is an extra cost to it. You need somebody to do more analysis, somebody to do more like calculations to see how much material they can take off. So there is a fine balance. And that was one thing where you need to understand what your certification deadlines are and how much of the continuous improvement effort you can put in. So that's what I would say when it comes to like the cost cutting, and then it's a fine line between cost cutting and continuous improvement.
Just keeping in line with what Parvesh asks.
Yeah.
Uh, like you said, a lot of your work is analysis, and a lot of
Yes.
analysis is now done on software. So,
Yes.
do you use legacy software which is available on the market, stuff like ANSYS, stuff like SolidWorks, or do you have the company investing into proprietary software that they've developed on their own with fixed modules that represent their own aircrafts? And is it faster to do analysis on such software?
Okay. So with analysis, we use mostly commercial software that is available. In most universities have software like that for free. Like
Right.
as you mentioned, what happens in structures is you might get a company who would say, within your software, we need one particular model that is specifically for us. And software companies are willing to do that for you. If you are a company that is a major source of their income, yes, they would happily create a model that needs to do something particular, So that is an option, but most of the software we use is commercial. And within teams, for instance, there might be somebody who might develop a hand analytical Excel sheet, for instance, with macros, to speed. Automation is one of the things that's encouraged, so usually under the continuous improvement, efforts. So it's somebody makes up a tool that the team uses, but most of it is like commercial software that is available on the market.
So continuing on from there, how much has AI disrupted your work? Like, has it disrupted your work or helped you? Do you use it at all?
Yeah,
What is the
yeah,
situation
yeah.
there?
it's a very interesting concept because when AI came into the scene, most aerospace companies were like, we are not touching that. I've seen it being adopted now, but with limitation, because the most companies like to have their software and their processes confidential and proprietary. So with what I've seen, it's it comes into play with questions following up. But with aerospace, I haven't seen it. We do not use it for, let's say, write these calculations or how would I solve. You might get it to give you a briefing on how to solve it, but the calculations have to come from you. We are always told it's an assistant, but it's not going to do your work for you. So would it phase people out? I don't believe so in aerospace. But what I believe is that with AI, it's going to phase out the engineers who neglect it in the long run. So that
Right.
is the way I see it. Yeah.
The problem is not the use of AI or the implementation of the AI. The bigger problem is like FAA and regulatory bodies like accepting your work based on AI. Like they will not accept it because AI is not a certified tool to use for your analysis, right? So unfortunately, structures falls under those critical or supercritical systems where, yeah, I mean, it's not a system, but it's like that aspect of the FAA certification where it is supercritical and like maybe catastrophic. So they
Mhm.
would not let like AI prompts like drive analysis. You would ultimately have to do it by hand or show proof that it has been done through approved tools for the FAA or for EASA. So hence, it's not that AI cannot do the job or AI will not come in the future, but it's just that approval of those tools and FAA agreeing to those terms and conditions of using AI, it's a long way to go. But yes, as Nee said, if you ignore AI, yeah, you will be phased out soon. So you have to be, ready for the transition. So
Yeah. Yeah.
And then you mentioned continuous improvement, right? So from when you started to now, there's been advancements in like materials, composites, things like that. Has that like have you implemented new types of materials? Have you done the testing for them? Have you done something like that along those lines?
It's in terms of materials, it's mostly metallic and composites. With composites, you do have glass fiber, carbon fiber, you have things like that. So those are, with structure, they are not necessarily new materials. It's just the implementation of where they are used. So for instance, with winglets, most people like to use there's more curvature with winglets, so most people like to use some sort of carbon fiber. But with the main wing, you do have carbon wings, so carbon fiber wings. But again, when it comes to structure, the certification process is very complicated. So phasing in these new materials is a challenge. So they usually phase them in a little bit at a time. Let's say a control surface like the spoilers, the ailerons might be a new material, but the rest of the wing might be metallic. So we see things like that where they're new materials but phased in slowly. Yes.
You have the unique experience of working with a private jet manufacturer as well
Ye-
as a commercial airline manufacturer.
Yeah.
Uh, is there a difference in the way they approach designing an aircraft, especially the structures? And is there a difference in the type of materials they use? Because there is a different application where you're making one for luxurious flying and one you're making for a sort of economic flying and for possibly larger routes with a larger amount of passengers. So do you feel that there is a difference there?
I'll say the overall design concept is very similar between the two. Like as you said, you have a luxury group, which is a small niche group within the private jet companies, and then you commercial where you're looking at hundreds of people on an aircraft. But one of the main differences I've seen, for instance, is that you have with the private jets, you have them flying at higher altitudes. And what they love to have is the pressure altitude within the aircraft. They like to have that at a lower altitude, which means like as compared to a commercial jet where it might feel like you're on a mountain with the private jets, the altitude is set that it feels like you're closer to the ground. So with that, your sizing might vary, but the design concept is pretty much, I would say, the same. You know, what what things where I see differences are, for instance, where they mount the engines. Usually commercial, depending on the size, of course, you have engines mounted on the wings, whereas with private jets, in most cases, if they're like turbofan engines, it's usually mounted on the rear of the fuselage. So the concepts vary by company, by the size of the aircraft. It's very difficult to say, okay, business jets are like this, and like commercial jets are like that. But in general, private jets are made for comfort, so there's little to do with baggage within the cabin. That's one thing I've seen where it's like you have the full cabin, baggage is stored in the back, and it's more of whereas with the commercial, you have your baggage within, so it's more compact, for the passengers. You know.
Yeah, that's interesting.
That's, without revealing the exact confidential details,
Yeah.
can you give us an example of a real world problem that typically lands on your table? And has there been any extremely weird requests, especially while you were working in the private jet manufacturing company, structurally, that you had to make as an edit to the aircraft?
Okay. So that's a good one I'd give was that was one time I used to work on the door, for instance. So with the private jets, the door is usually the main entrance. There's no jetway for the ones if it's a small aircraft. So the door is your staircase and it is a pressure block, for the aircraft to make sure, yeah, it's pressurized throughout. So every now and then there's a request because with private jets, you have athletes going onto these aircrafts, and you have these guys are much larger than the average human being. So there's always this condition of how heavy can the person be to be on this
Right.
door, on this staircase. And there was one time they gave me a weight to check if the door would still hold, and I was like, who is this person? Because I don't understand. I don't understand how that you can give you that weight requirement. And the thing with structures is you might have the weight and you have to usually add an extra 50%, just to account for things that could go wrong. Somebody jumping on the door, for instance.
Right.
And especially with the private jets, the door has to open and it is cantilevered, so it's pretty much not touching the ground. And you have to make sure there's enough deflection so that it never touches and the paint job is never stretched. So I think that was one
Right.
of the challenges where I was like, oh my goodness, this door thing is a challenge on its own. Yeah.
Yeah. I remember the door situation, and like, I mean, not from a structural standpoint, from a
Yeah.
system standpoint, we
Yeah.
had to dedicate a whole team to
Yeah.
design the door,
Yeah.
literally, like, because there were so many different weird requests that were coming. It was not just the weights, but also like the dimensions of each step and how it
Yes.
rolls out and
Yeah.
how quickly does it come out. Because there was an incident in, like, I don't know, some other private jet company where I think the crew was trying to open the door and the cabin was already pressurized for some reason, and it just snapped directly under somebody below,
Yep.
and
Yep.
injured them, like, fatally injured them. So
Hmm.
that was another case study that was going on. And then with the G500 600, I think, at least for me, what I remember was we had to dedicate a separate team, I think, just to make sure that the doors can, like, take all the requirements from all the billionaires that are out there. So it was insane. Yeah.
Have you ever had like a request asking you to open the doors like a Ferrari or something?
Well, there is like there are people who've asked for like doors to open
Really?
faster, you know. Oh, but no, not in terms of like a Ferrari. No, that we don't change. It opens downwards with gravity. That's it. But no, a Lamborghini Ferrari doors, that would be interesting. But no, that I don't think I've got that request yet. Yeah.
Thank you.
Yeah.
Thank you for answering it like that. But yeah. So let me like let me talk about things from my experience, at least working on the same aircraft programs like together, at least for a while. So how do you think it's like, how big of a challenge it is when you have 2 or 3 parallel aircraft certifications happening together, and at the same time, like, you might, like, I mean, for me, at least from a systems perspective, I'm like, it's the same aircraft, like what's the big deal, right? I mean, it's going to be a little bit of loads of like the electrical loads changing or the wiring lengths changing for us, but from a structural perspective, how big of a change is having one extra, like, section added to an aircraft to increase the cabin space? Like,
Yes,
how big of a change is it?
exactly. From a structural perspective, it does change a significant amount because all of a sudden, your the center of gravity changes. And once that changes, it comes into play of so you add a new section, the maximum takeoff weight changes, the maximum landing weight changes as well. So the first thing you're looking at is the wings, the landing gear. So all the things that take impacts during landing. And even during just like the cruise flights, your gust loads you might have because you're carrying more load, your wing flexing might be different. So I know from the surface it looks like, oh, you just put a section here, you put a section here, you stretched it out. It's the same cross section. So why is it such a big deal? It is in terms of the different things that could go wrong. And that is something we have to consider. And we spend like a significant amount of time, checking to what could the differences that could impact the aircraft. Yeah.
Uh, Honestly, while we're talking about certification, it is my belief that aircraft structural integrity is the backbone of safety and certification for any aircraft. So, from your perspective, why is the stress analysis such a crucial element of airworthiness? And since it is, what sort of process do you typically have to justify that a structure meets the certification requirements? So, just shed some light on that.
Okay. So you're very correct. Like well, everything is important for like the certification effort, but structural efforts are very important, mainly because throughout the life of the aircraft, the structure is mostly unchanged. You're not taking off the wings and putting on new ones. You might change the landing gear. Most of the frame stays the same. You might be able to change the radome. So you need to be able to understand that, yes, let's say within the wing, you have all these different ribs and different structures that you might not even see because the wing contains the fuel. So once the aircraft is fueled, until maybe the next 4 years, nobody is going to be inspecting it. To inspect what's within the wing, all these panels need to come off, and somebody's head needs to go in visually inspect. So the main reason that structural and integrity is important is there are very many sections of the aircraft that you do not see that nobody goes in once it's covered up. So it needs to last the entire life of the aircraft. In terms of efforts, usually a company would have an authorized representative. This is somebody within the company who has been designated by the FAA to ensure that everything within that structural manual is followed. For instance, like I mentioned, how you have your regular load and you add 50%, to
Right.
account for anything that can go wrong. You have structures has all these different load requirements where the designated representative is making sure everybody who's doing their calculations is following the design requirements, and those are set forth by the structural manual.
So it's a very interesting thing that you said that overall your structure is mostly not changing. But in case an in-service aircraft needs a repair or a modification, then do you have a role to play as a stress analyzing engineer if this said modification somehow changes anything related to your structural integrity or whatever process you have followed to ensure that this aircraft is airworthy?
Yes. So there's usually a post certification team that takes care of that. So there is a repair team. They're usually called the in-service team. There's different like set of stress engineers, and they look into things like, for instance, one thing that happens in most airports is somebody is driving a baggage cart, drives it into the side of the aircraft. That happens every single day in any major airport. So there will be a dent, there will be a scratch, there will be a crack. Um, so there are teams that look into it, and there is an engineer who's usually spent time in the research and development stage who looks at it and it's like, okay, this repair is not deviating from the standard certification that the aircraft was certified to. So yes, there is somebody who knows about the certification. And once in a while, it does come back to the research and development like, hey man, this is a major hole within the aircraft. Something I've seen where the aircraft was in service and it was put on jacks. And for some reason, one of the jacks slipped and punched a hole through the wing. So it comes to a stage where you're like, how much of a repair can we do? How much can we take off? In cases like that, there's a large part of the section that's scrapped and like a new section of skin put on. But there are always these challenges of how much do we need to do, and also the cost is a factor because strapping a wing, I've never heard of a wing being strapped in service, but that would be millions of dollars in cost. So you're trying to save the airline cost and not deviate from your certification regulations. So there is the back and forth, and something always has to give. So that's what I see with those efforts.
The certification game is always something has to give, right? I mean, that's
Yes.
always the case, like the money versus the regulations. But the question that I have for you was like, like like the modern aircraft manufacturers, all of them have gone towards composites and stuff.
Yes.
As a systems engineer, obviously, I do have an academic knowledge of what composite material is or what,
Mhm.
the carbon fiber layering or whatever those techniques are. But why are they kept so secretive? Like, for example, you're saying like repairs stations would have to fix them anyway. So if there's like
Yep.
a issue happening, they can't scrap the whole wing, right? For example, if something like that scenario happens, then why are the modern aircraft manufacturers not willing to how do they think their business model is going to work when they're not willing to share those, or do you know if they do share it but they don't like completely share it, sort of a thing, like the
It's
composition of their materials?
it's challenging because especially with composites, it's the newer kid on the block as compared to like metallic aircraft. So we are still in a stage where every aircraft manufacturer likes to keep what made their composite aircraft different proprietary. So of course with repairs, they would like to keep the repairs. They will have a repairs team that supports the airlines, but the airlines also want to know, it's like, hey, what's this made from? Like, what are the different composite layers that are used together so we can make it on our own? But the aircraft companies always like to keep that proprietary. Do I see that changing in the future? Yes. If there's something that's more advanced than composites, then people will be willing to share. But until the next big thing or the next big material is out there, companies will keep their data proprietary.
Because like I think the bigger challenge over here is the aftermarket things
Yes.
like that the customer would like to do. Like most of the aftermarket challenges, at least now that I've transitioned from actual aircraft manufacturing towards aftermarket world, I can say that this is the biggest challenge that we have, at least like when we are dealing with like the Boeing and the Airbus new modern aircrafts. Like we cannot do any STCs because we do not know what loads and like what we
Yes.
can do with the modifications after
Yep.
it's been delivered to the customer. So that's one of the biggest things. Like it just amazes me that like they have sold this aircraft but they won't tell like what it's made of, because we cannot do anything with it after that. So we have to keep going back to the manufacturer and then request, and by the way the request also costs money. So
Yes.
it's just I feel like that model was like, I don't know if it was well thought out, but it's weird. So yeah.
And you're very right. It's always going to be money where you want to know or let's say you want to put a new antenna, you're an aftermarket company, you want to put a new antenna. Um, we're not telling you the loads, so obviously it's like, yeah, unless you pay us and it's usually enough. They won't give you the exact loads. They might give you something about this is what the interface loads are. So where you're going to bolt the structure to the aircraft. So that's all you get. And then you figure it out. But that's about it. So the information that's shared is very limited and it always comes at a price.
Yeah. Yeah.
Talking about challenges, personally for
Yes.
you,
Yeah.
what is the technically most difficult structure of an airplane to analyze? Is it like a wing section or a tail section, the fuselage, or do you just look at, say, joints and rivets and stuff like that?
System
Ac-
stress.
Actually, I mean, those are good questions that every stress engineer would have a different answer for you. But I think one of the most difficult I worked on was the door electromechanical system. So as I had mentioned before, yes, the door is a staircase, but to get it to open, you need to get it to depressurize. Need to get it to unlatch. There are all these different, rods going into place. You need to make sure it doesn't jam because like one of
Right.
the problems we have is some of these jets are flown in cold sections or different countries where it might snow. So the door could freeze, and your system needs to be in such a situation where it's still able to unlatch the door, let it open within the time, because it's also an emergency escape. So
Right.
there's a time limitation where it has to open within a certain amount of time and get everybody out. It can't jam when it's an emergency situation, and then we're all like, how are we getting out of this aircraft? So I would say the electromechanical system of the door was by far one of the biggest challenges I had to work with. Yeah.
Okay, so moving to sort of advanced technologies, things that is there like emerging technologies, additive manufacturing, different types of materials, something that you are looking forward to maybe coming in the future or that you're able to see in the horizon?
Yes, I love the idea of additive manufacturing and 3D. So 3D printing, additive manufacturing, those pretty much fall in the same box. 3D printing is one of those things where I see, aircraft manufacturers moving towards because many parts are provided by suppliers, and we've talked about repairs. So if manufacturers can pass on information where let's say an airline says, "Hey, we broke this part. How do we get this? Or can you send us maybe a software or the soft copy of this part so it gets manufactured within our facility, the airline, and then we put it on the aircraft. You guys just are the oversight." That is something I'm looking forward to because it improves the relationship between the manufacturers and the airlines, and it speeds up the process of repairs such that aircraft aren't grounded for so long because one person is manufacturing and has to provide it to the aircraft or to the airline and then get approval and so on and so forth. So 3D printing, additive manufacturing, that's something I'm looking forward to in the future. The challenge with that is the certification, as always. So getting your parts certified, it works for smaller parts, but when it comes to bigger things like the wing ribs, for instance, there are more challenges when it comes to that because those are like primary parts of the aircraft. But yeah, for smaller systems, those I believe are easier to certify than like major parts of the aircraft, like the frames of the fuselage. Yeah.
What about the use of smarter materials? You mentioned
Yep.
studying in college about smarter
Yes.
materials, especially the ones that have started now flexing under different
Yes.
electrical loads. So, is
Yeah.
that something that is certifiable? And do you see that becoming sort of usable in commercial airlines?
I see definitely it would for sure be implemented on smaller aircraft first. I see it coming into play in the future, most definitely. I see, especially with control surfaces. the advantage with structures like that is you have a smoother wing profile, so your aero is much better in terms of the aerodynamic flow around the wing. So it will come into play. I can guarantee it's going to come into play in the future. Certification it's I know some companies are working on certifying, control surfaces where that comes into play. Some I know are doing something where you have a redundant structure. So you still have the original hydraulic actuators, and you have a combination of the hydraulic actuators with these electromechanical materials coming into play. So it might be a hybrid system at first, but eventually I'd see it going where you have electrical current coming into the being used to control your surfaces, your control surfaces. Yeah.
Kind of related, but have you guys seen the design of the Boeing 777X that was just showcased I've forgotten what program this was, but it has the folding wingtips which sort of
Yes.
elongate and then they fold again.
Yes. Yes, I have seen that. And it's a very amazing structure. Yeah, yeah. And of course, the main thing was they wanted to have like such a wide aerodynamic profile of the wing, but now parking it became a problem. So
Exactly.
yeah. So yeah, that was the challenge with that.
Talking about sustainability, do you see any materials that can be used to make design or any processes that can be used from a structural side that can make airline manufacturing more sustainable?
Um, so it goes back to the continuous improvement. It's with sustainability, most of it, from my perspective, goes towards the engines. So with the engines, the efficiency of the engines dictates a lot of the sustainability of the aircraft. But airlines on their own do things, for instance, to take weight off so they discourage passengers from taking as many suitcases, like back in the day where I believe the limitation was 32 kilograms for every suitcase. Now they've reduced it to 23 kilograms. So there are things like
Right.
that where airlines come into play. You take the weight off, you're flying with much less fuel, and that increases your sustainability. So it's a partnership between the manufacturers and the airlines, but it's mostly an engine efficiency. That's one of the main drivers of sustainability, in my opinion.
Okay. So at some point, right, like most of the aircrafts we have now are like 20 years, 30 years old. So at some point we need to recycle them or scrap them, things like that.
Mm-hmm.
So for future aircrafts, like in your designing of aircrafts, do you take that into consideration, that the end of life cycle management, how to make it more sustainable, how to properly scrap the parts, scrap everything, or recycle the parts, that kind of thing?
Yeah, we we look into getting like the most out of the life of the aircraft. So instead of 20 years, trying to get it to about 30 years. But that usually falls within the scope of the airline because, airlines with more money, they're able to scrap planes at a faster rate. They're like, okay, yeah, we're getting more efficiency from a newer aircraft, so why not scrap this earlier? They might go to a 15-year mark instead of the 20-year mark. Whereas a airline that doesn't have as much money might push it. They might have an aircraft. First of all, they'll buy the aircraft at 10 years old and try and push it to 25, 30 years old. So it's a it's a tough challenge between airlines, manufacturers, you give your limits of, yes, it shouldn't go more than this, or if it's going more than this, you need to change these particular parts of the structure. So it's a balance between manufacturer recommendation and airline affordability, how much they're willing to spend on scrapping. But when it comes to scrapping, the manufacturers, as far as I know, are not typically involved with where the aircraft is scrapped, how it's scrapped. Yeah, that falls into a different company's scope.
So yeah, I mean, just to shed a light on that, it's part of like little bit of a systems engineering part where operability and like, the end of life kind of like transitions, like that's where those requirements are written, and to show the product life cycle from infant like stages till the mortality stage, right? So like, there's a whole life cycle, what do you call that, planning that gets done, and then the scrapping and the exit strategy also is done in that way. And also the airlines, for example, there are different kinds of airlines, right? Like there are certain airlines, like we have Indigo in India, for example. They do like they only buy new aircrafts, and they only keep those aircrafts for 5 years, and then they put it off in the resale market, right? Because they don't want to deal with any later on, like after 5 year like problems that any aircraft has. And whereas, but then there's also other kind of airlines which will only buy like older aircrafts and then sustain their fleet with like making sure that they get cheaper aircrafts and more number of aircrafts to fly. So that market then takes care of itself on how they have an exit strategy of scrap material at that point. So there's just two different ways of thinking about that. But
exactly. And there's also the difference between leasing the aircraft and buying the aircraft. So some companies are like, we are doing a lease only for all our fleets. So
yeah,
they would lease it for maybe 5 years, 10 years. As to what the leasing company does with the airline aircraft afterwards, they're like, yeah, that's not our problem. We lease it 10 years. You give us a new aircraft. We lease that, we use it, and then give it back to you. So there's a leasing agency that comes into play with some of those things. Yeah.
It's just one question from me before we move on to the next section. Where do you see your sort of role typically transitioning into as we move on to more futuristic technologies? And what is one thing you feel is the most misunderstood part of your job?
Well, a lot of it depends on the design of the aircraft. And the way I see it going for the next stage of aircraft development, I see more of a blended wing design. That is what I feel the next goal of design aircraft that are going to come into play. So for that, what it means is the stress engineers will be looking at how are we blending this aircraft within satellites going to fit within current airport sizes and parking spaces. So the main thing is the design guys say, hey, we're going in this direction. And we are like the supporting staff that are like, okay, fine, this is where you want to go. We'll support that push with you. What's the next question? Sorry, I forgot about the second part of your question.
What's like a most misunderstood part of your job?
Okay, so most misunderstood. I'll say from the systems stress perspective, most people assume that we just worked on like the brackets that held up the electrical systems. But the main challenge, especially with system stress, was you're always interacting with primary structure. So below the aircraft, for instance, you have all these bulkheads, which are the different sections that contain pressure of the aircraft. You have to put holes within them. You need to understand that putting a hole is usually a source of crack propagation. So putting holes in, you need to understand that, hey, at this section of the structure, if I put holes in here, am I going to cause cracking, which might cause, some explosion within that section of the aircraft? So it's things like that where people assume that, oh yeah, we just worked on brackets as system stress engineers, but it's a very complicated system of you're working on structure that people don't feel is very important, but you're going through primary structure as well and need to understand the flow and also even the interaction within systems. If you have electrical systems, you need to make sure they're not really interacting with any fuel systems. And if they're hydraulic systems, that they are separate, and they're still running along the length of the aircraft. So there are all these considerations that you need to have.
Yeah, the biggest one being the EMI separations as well. That's also another thing that, yeah. All right. So anyways, I think, let's go back to what we started off in the beginning. So, yeah. So, what do you think is the biggest like difference you found like between like EU versus America, like in terms of like coming in for like, in terms of academics?
Academics. So back to EU, where it's like the moment you get in, there's very little in terms of introduction to this or introduction to statics. The moment you get in, you're doing straight hardcore aerospace courses. So I know with like the US system for undergrad, there's more there are these courses that warm you up. You might do like calculus, I mean easier versions of calculus to warm you up. Whereas with the European system, it's more like, hey, you're here, you chose to do aerospace, so this is what you signed up for. So yeah, no, they get from day one with the European system, you're in aerospace. But I feel with the American system, you're still giving all these courses where you're not necessarily you're doing engineering courses, but you can still vary between at some point say, okay, yeah, I want to focus more on the mechanical route than the aerospace route. Things like that where you're molding yourself as you go along. With the European system, it's like you chose aerospace, you're doing aerodynamics from day one. Whereas with the American system, you're doing courses to make you feel like, okay, I can do this. But with Europeans, you need to know that you're ready to do this before you even get there. Yeah.
So for a prospective student who is listening
Yeah.
in today,
Yeah.
based on what experience you've had in both these setups, what advice would you give, and how would you guide them to move on
Okay.
and choose?
If you have to choose between the European system and the American system, that is a tough call because I would say they're both brilliant. The advantage with the European system is it's 3 years. So yeah, if you're done 1 year earlier, you can start working earlier, of course. But even though it was 3 years, most people do not finish in 3 years because some courses are so difficult, you have to spend an extra semester. I know there are people who spend 5 years instead of 3 years. So there are situations like that. But and one of the good things with the European system was the cost. For instance, I believe my tuition was about 5,000 euros a year. Whereas in USA, if you want to go to one of the big private schools, it's about 40,000 US dollars, which is a significant amount of money to go to school. And that's over 4 years. So 40,000 by four, 160,000, that's significant. So cost, cost and the quality of education, I will pick Europe for opportunities in terms of jobs afterwards. I would say USA seems to be the better deal. Yeah.
I think it's the job perspective and the real R&D that you can get to do more. I think the opportunities are more over here in the US. So yeah. Um, I think this is like an open forum question but I wanted to know your opinion more, Nii. Like, why do you think the prospective students or like current listeners, whoever is ambitious about becoming aerospace engineers, what they should be looking forward to in the structural field? Like, why they should choose structures, for example, like as a field?
Because like in relation to structures, you have design. Design is a necessity. It's but you always have to analyze the design. It's a similar relationship between architects and civil engineers. You might have the most beautiful structure in terms of like a building, with all these caves and twisted buildings, for instance, like what you see in Dubai. But in the end, it has to hold in terms of the structure when you have all these winds and storms hitting your structure. So as much as yes, you do need design engineers, you need to have a structural engineer who has the final say as to this structure will hold. I believe in it, and it's going to last the entire time that we've said, possibly the 20 years that we've said. So I I would always go towards, well, of course I'm biased, so I would always go for a structural engineer. But it's a necessity within the structures and the aerospace field as a whole.
So, I mean, does that mean there is a need for more structural engineers in the industry?
There would always be a need for structural engineers. It's always going to exist. I know we talked about AI. And no amount of AI is going to replace a structural engineer. It's similar to we're always going to need more pilots. The more planes you produce, the more pilots you would need. I see the linear correlation with structural engineers as well. I don't see computers flying the plane or AI flying the plane, but they would always be a supporting member of engineering and pilot community.
So, as a follow up to this, as per your opinion, what skills does a young engineer need to have to become a good stress engineer, especially
Oh,
in a major OEM?
yes.
Yeah.
It's math, physics, and then it's most of the the bachelor courses, for instance, the statics, mechanics of materials, and dynamics. Those are the core of what a stress engineer works with. Programming is also an advantage. So, of course, once you can automate your processes, speed your processes up such that you're not doing. And with automation, in most cases, an Excel, if you're very good with Excel, that covers most of what you do. But you could put in macros to speed, your number calculation up, or your inputs, processes, and outputs. So Excel, statics, mechanics of materials, dynamics, physics, and your math courses. Those are the core of what a stress engineer needs.
And what about like a mindset? What sort of mindset makes someone good at stress engineering?
I think curiosity is the mindset I would definitely put myself towards. So somebody who is always willing to ask questions, who is not struggling. There's no point in struggling on your own in stress engineering. It's like you start with a problem, you get stuck, ask a question. There's always somebody with more experience than you. Ask questions. Get a mentor, for instance. That was one of the brilliant things that my first company gave me was the moment you step in, you have a mentor who is guiding you towards, okay, this analysis, I see your thought process. It's not wrong, but a better way to go is this way. Why not try this or that? And even along the progression of your career, they are always like, oh yes, you've done this for a while. Why not try this part? You've done maybe systems for a while. Why not try the wing? Or why not try the fuselage or the empennage, things like that. So having a mentor is always beneficial, but the mindset of curiosity, that's the main thing I'll push towards anybody who is interested in structural engineering.
So keeping that in mind, do you have a particular moment or a particular project that you're really proud of, something that you were curious about, something that you did accomplish that it's really close to you?
I would say there was one time I did work on, well, the baggage door. I did work on the main entry door, and one of the other projects I worked on was like the baggage door of the aircraft. And it's one of those things where it hasn't been changed in many years, but for some reason, you know, the door structure hasn't been changed, but the opening structure and mechanism had to be, they wanted to modify it a little bit. So, it's one of those things where I was in the group of, do we really need to change this? It's worked on so many different programs. Do we really need to change this? But also the challenge of, trying something different. And these were like systems and brackets that we were putting in place. And I believe I was the one who was working mainly on the brackets. So everybody knew it's like if during the opening sequence these brackets failed, it was on me. So when you have that thought in mind where you're like, wow, okay, if this thing fails, everybody is coming back to me to be like, okay, you are the one who analyzed it. You screwed something up. That's when you're faced with that reality of I might screw this up, but well, I haven't gotten a phone call yet. So clearly it's working in the field. So it's that challenge of this is your responsibility. You need to make sure you put all your knowledge and understanding of aircraft structure together to make sure it is a success. That that initial fear, but the success that comes after it, that's usually one of the things that I'm really happy about. I still haven't gotten a call about anything I worked on, so I'm really grateful for having a career like that.
That's amazing. I think like from a systems perspective, like from systems engineering's perspective, like I don't think so any amount of academic work that I have done helped me to like have a easy path in the industry, and it's always been a lot of like exponential learning once you get into the industry, because nobody teaches you about regulations and how regulatory aspects work when you're in college, right? So that was my challenge. But what do you think as a structural engineer? Like, is there something that easily transitions from academics to professional, or is it again the same thing where there has to be a lot of learning curve that needs to be done?
I think in the beginning, the learning curve, they keep saying it's like drinking through a fire hose. It was like, I mean, I've been through grad school and undergrad, and they were good schools. Like, why is everything so new to me? Like, why didn't they teach me this in school? So it's that thing of there are all these new processes you're learning, as you mentioned, certification. I got in and it's like, why didn't anybody why wasn't there a class on certification, at least in grad school? So there are all these things you don't learn in school that you have to learn on the job. But it's the mindset of, okay, yes, I learned something in school and I'm willing to learn something new. That's always going to be one of the things that separates the good engineers from the regular engineers.
Great, yeah.
So, just a yes or no question. Have you sat in an airplane that you've worked on?
Well, I've sat on an airplane. Yes. Yes. Well, so with a commercial, yes, I've sat in most of the planes that my company makes or manufactures. With a private jet, I have sat in it while they were sitting on the ground, but not during
Ah,
flight. Yeah, yeah. And trust me, it was one of those experiences where I'm like, it pushes you to think. I'm like, it would be nice to be a billionaire, millionaire one day, because yeah, that experience of sitting on a seat, it was something different. It does change your life for sure.
I think even if you haven't sat on the private jet that you worked on, I'm pretty sure the first flight of it that you saw, the experimental first flight, I mean, that was, at least for me, it was one of the proudest moments of my life. Like working on it, like day and night in the labs and everywhere, and then seeing it being announced as its first flight going off. That's I think that's what drove me to be an aerospace engineer, at least, like design something that is flying.
Yes,
So
yes, yes.
Hey,
You're
you
very
never
right.
know. Like, if this podcast takes off, maybe we'll have our own jet and we can all go and party in the jet.
yeah,
Yes,
absolutely.
yeah. And since I'm your first fan, I hope to be your first passenger as well.
Oh, we're sitting
No,
in
you
your
will.
flight, man.
No. What he meant is like we own the jet, and you're gonna be our guest in there, and the
Yeah,
next podcast would
Yeah,
be
yeah.
on that aircraft.
yeah.
So
Well, okay, that's even better. Yeah, yeah, yeah. Sitting, having some champagne. I'm looking forward to it.
is
So
that
my
what you see
usual
next as
question.
part of your journey, apart from like the research and the leadership stuff? Hopefully, becoming a billionaire and owning a private jet.
Um, it's always good to dream. It's always good to dream. So I would say yes, I'm shooting for the stars. So yeah, at some point, yes. Especially to own a jet that I know I have worked on. That would
Right.
be, I think, the peak of my existence.
So now to my question. Do you watch anime or play games? And what, if any, media sort of inspires you to stay in aerospace or aeronautics?
Okay. We I'll start with anime. One of the animes I watched on Netflix recently was The Blue-Eyed Samurai, which I felt that was a really good show. I think there's a season 2 supposed to come out, I think, next year, so I'm looking forward to it. When I was much younger, I used to watch Samurai X. That was with his double-edged sword. I think for some reason, one side of his sword was supposed to cause death, the other side
It's
didn't cause
reverse
death.
tinged.
Reverse edge. Yes, that is exactly what it was, where it didn't kill or something strange like that. But yeah, Samurai X was another one that I watched, and of course, Bleach was what I watched in high school.
Us.
So
None of them
but in
have
terms of
anything to do with aerospace.
yeah, no, I mean nothing to do with aerospace, of course. Yeah. So I know I deviated. I just once you mentioned anime, I just went off a tangent. Anime and aerospace. But yeah, in terms of what keeps me in aerospace, I believe that was the next part of your question. What keeps me in aerospace is the ability to work on something much bigger than myself. So it's like you're working on these planes, you know that, hey, at some point your loved ones are going to be sitting on these planes. So you cannot afford any fatalities, any casualties, any part of your structure that's failing. So you always, and it's all to do with integrity of, okay, your calculations, the best of, to your knowledge, the best of what you've done to your ability. So that's one of the things where it keeps me, you know, question, okay, even after work, I'm like, okay, did I do everything? Did I calculate everything the way I was supposed to? Can I do this better? Can I go check in it tomorrow, see if there's anything I could, adjust, to see if or anything to verify my calculations, things like that. So the main thing with aerospace is working on something bigger than yourself and knowing that, hey, at some point you will be sitting on this aircraft. So it has to be intact and structurally the best that it could be.
That's the goal every day. That's the goal every day. Uh, I'm I'm really glad we had this kind of discussion and this kind of like back and forth talk. Uh, what do you have to say about like to our audience? Like, do you have anything to talk about? Like, the platform is yours. Like, if you want
Okay.
to say something.
Oh, so I mean, thanks for that. I just had a few lines or pieces of advice I'd gotten from bosses over the years, and
Yep.
I think like one of my first bosses, one of the things he emphasized was, hard work in the wrong direction is still wrong work. So, which goes back to my point of, you're stuck. Ask questions. There's always somebody who's more experienced than you. So, ask questions. Be curious. And another boss also mentioned that you should never treat, no matter how small the task is, never treat it like it's not important. Because it's usually the quality of work you do on the smaller tasks that them give you bigger tasks to work on. So put your best into everything that you do. And of course, I do remember us talking back in the day about, how changes feel like it might be a mistake. So you're in one company, you move to the next company, you're always doubting yourself, like, was this a mistake? And I would say always embrace new beginnings because there are always going to be new challenges. There will be new things you've never heard of and new things that you've never worked on. So those are the pieces of advice I'd give to like anybody who's listening. So thanks for that.
I think all three of them are brilliant advisors, which I think
Yeah.
young aerospace engineers nowadays, especially in today's generation, like how they want quick success. I think aerospace
Yeah.
is a field where it is like a marathon, like you have to
Yeah.
be on it, and those advices are pretty good,
Yeah.
especially the last one. Like
Yeah.
you got to jump into the beginnings, like you cannot
Hmm.
hold back with the past and be confused. So
Yeah. 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 That's very true. Yeah.
that's
The
amazing.
hard work in the wrong direction line is so good. I've already written it down. I'm definitely using it. Thank you.
Yes, yeah, no, you're welcome. No, he gave this to me in like 2014. I still hold that to this day. Hard work, wrong direction. Yeah, it's still wrong work. Yep.
Yeah, my boss was not as polite as yours to give me the same advice, but you know some of my bosses back in the
Yes.
day. So you know what they gave me. So
Yeah.
yeah,
Yeah.
they called me names. But anyways, one like I think one last question before we actually wrap up is what's your passions outside of aerospace? Like what do you think you look forward to like outside of work, like outside of aerospace in general?
Okay, so I didn't talk much about this, but yes, I do. I am a pilot on the side, so yes, I do leisure flying. So I'm both certified in single engine aircraft and gliders. So well, cost-wise, gliders are cheaper. So I do, especially in the summer period, I do go gliding almost every other week. That is one of my main passions. And since I moved to Wichita, there are like bicycle paths everywhere. So I do lots and lots of cycling, of course, once the weather is good. So cycling, gliding, those are my main passions. And well, since I got a place, I'm also a big fan of grilling food. So that I do not play with, yes. So anytime you come to Wichita, we're doing some grilling so that I'll keep on my agenda. Yeah, if you're ever in the neighborhood, yes, I'm grilling. It's Texas style. I'm grilling either
Nice.
brisket or pork ribs, something. We're definitely doing some grilling. So yeah, those are my main passions.
All right, guys. I think it's safe to say we had like a
Yeah.
great episode, and we had a great conversation today.
Yeah.
I think we had a great insight into the world of structural engineering, which always I always dreaded. I always
Yeah.
like was very intimidated by.
Yeah.
So thank you, Nee, for sharing all your
Yeah,
experiences and answering all, like a lot, like all of our questions.
Yeah.
And so thank you guys for listening. Please do give us your ratings on like every single platform that we are posting. We are seeing all the views, but we are not seeing the subscriptions, so please help us. It helps us a lot. It motivates us a lot to bring in more guests and also make more fans of the channel. And also please do reach out to us if you have any questions, any guidance, anything that you guys need from our guests. Like if you have any direct questions for Nee, we're going to post his LinkedIn bio and everything into the description, as well as like any kind of contact details we get for Nee. But if you want to reach out to Nee through us, like please do reach out to us through our email address, like groundcontrol to majornerds@gmail.com, and we will make sure that we direct it to Nee as well. So with that being said, it's a wrap. Thank you so
Yeah.
much, guys. Thank
Yeah,
you for
thank you. Yeah, thank you for having me. Yeah.
See ya.
Yeah, see ya.